In the first section of chapter 12, we talked about arc length and circumference. Circumference is the distance around a circle, somewhat like perimeter, or exactly like perimeter would be called in another type of polygon. And arc length is just a piece of it. So let's review a couple of those problems first. In number 1 here, then we're asked to find the length of the arc from A to B. Now, if we're looking for the length of the arc from A to B, we need to know the number of degrees of the arc. That's going to be the same as the central angle. And we need to know the radius, which they gave us. And then the arc length is equal to the fraction of the circle, 138 degrees out of 360 degrees, times 2 times pi times the radius, which is 23.7 inches in this problem. They asked us to round to the nearest hundredth. That's 2 decimal places. So the arc length here comes out to be 57.08 inches. A second type of problem that we had in that section was we were asked to find the circumference of the circle when we were given information about the arc length. Let's try one of those. So in this problem, they ask us to find the circumference, and they give us some information about the arc length, the part of the circle. These were the problems where we used proportions. And we compared the part of the circle to the whole circle. So the number of degrees in the part was 43 degrees. The number of degrees in a full circle is 360 degrees. The arc length in the part was 19 centimeters. And we were looking for the full circumference of the circle. And as we have always done in the past, we cross-multiplied. 43 times c, of course, would be 43c. 360 times 19 is 6840. We would have to divide to finish this problem. And the answer that we come up with is the circumference equals 159.1, and the label is centimeters. So that was in the first section of this chapter. In the section we just finished, we were talking about areas, specifically about areas of circles and areas of parts of circles. A part of a circle is called a sector. So let's go ahead and review one of those. We're looking for the area of the sector. To find the area of the sector, we need the number of degrees in the sector, which they gave us. And we also need the radius, which again they gave us. So to find the area of the sector, we take the fraction of the circle. The fraction of the circle would be 52 degrees out of 360 degrees times pi times that radius squared. Once again, they asked us to round to the nearest hundredth. So for the area of this sector, when we put all of that into our calculator, we get 147.03 centimeters squared. Remember, on areas, the units are always squared. Now, as happened in the first section, sometimes they gave us information about the circle, and they asked us to find something else. For instance, in this problem, they give us the area of the circle, but then they ask us to find the radius. We're going to use the formula for the area of a circle, which is pi times radius squared. We do have the a, that's the 82 pi, and I'll leave the units off because we don't need them except in the answer. And then we're looking for the r. Well, our first step is going to be to divide by pi on both sides. The pi's will cancel, and we'll have r squared equals 82. You learned how to solve these back in Algebra 1. It's called solving using square roots. We would take the square root of both sides. When you take the square root of 82, you get two possible answers. you get r equals positive 9.06 or r equals negative 9.06. Now, this will not work in this problem, the negative one, because radius has to be positive. So our answer would be 9.06 inches. And we can't forget the units on that. You must box your answers in this chapter. And that's because in some problems there are extraneous solutions. So if you don't box anything, we'll take it to mean that you don't believe any of them are truly answers. Now the rest of this section is going to be new. We're going to talk about segments in a circle. Specifically today we're going to talk about chord segments. And recall that a chord is a segment that has both of its endpoints on the circle itself. And a diameter is a special chord. It's a chord that passes through the center. All other chords would have minor arcs associated with it. The first new thing is if we have two minor arcs that are congruent, then their chords are congruent. So if arcs are congruent, which means equal, then their chords are equal as well. And that in itself will allow us to solve for some lengths. Here's an example of such things. When you look at this, you can see that the circles are congruent because they have the same radius, and you can see that we have congruent chords. GF is congruent to, segment GF is congruent to segment JK. We can see those markings. So that means that the arc G to F will be congruent to the arc J to K. So the arc G to F will have to be 80 degrees. Same as what they gave us there. Congruent chords have congruent arcs. Now that was pretty straightforward. Let's try another application of this concept. When you look at this diagram, we can see that we have congruent chords. AB is equal to BC. So, arc AB will be congruent to arc BC. If arc AB is 110 degrees, then the measure of arc BC will be 110 degrees. Now, if they tell us that the measure of arc AC is 150, I know that both of the other arcs are congruent. I know that arc AB is congruent to arc BC. So if I call those x, then x plus 150 has to add up to the full circle. So 2x has to add up to 110, or 210. So x would be 105. The measure of arc AB then would be 105 degrees. Each one of those arcs is half of the remaining part of the circle if you took the 150 away. Okay, let's talk about bisecting arcs and bisecting chords. If we have a chord that is a perpendicular bisector of another one, then that first chord is a diameter. So in other words, a diameter perpendicular to a chord bisects that chord. And it also bisects the arc of that chord. So a diameter that is perpendicular to a chord will bisect the chord and its arc. And we can tell that it's perpendicular by that right angle that's there. Let's try an example of this concept where we apply it. So in the diagram, we can see that we have a diameter. B to D is a diameter. And we can see that B to D is perpendicular to C to A. We have that right angle there. That means C to F has to be equal to F to A. So we can figure out C to F will equal 7. So we have 7 there. Now they've asked us to find the length from A to C. Well, A to C is going to be 7 plus 7, so A to C is going to be 14. A diameter perpendicular to a chord bisects the chord. And it also bisects the arc. The part we used was the bisecting of the chord. Let's try this one. When we look at this problem, we can see that B to D is a diameter perpendicular to the chord C to E. So it bisects the arc. Arc CD will be congruent to arc DE. We can set those two equal to each other then. 9x will equal 80 minus x. 10x equals 80. X equals 8. If x equals 8, then the measure of arc CD will be 9 times 8, which is 72. And DE will likewise have to be 72. And the whole arc from C to E will be 72 plus 72, which is 144. A diameter perpendicular to a chord bisects the chord and its arcs. The next new concept. The next new concept says in a circle, in the same circle, or in congruent circles, two chords are congruent only if they are equidistant from the center. So if these two are the same, EG equals EF, then we know that the chords CD will equal A to B. let's take a look at a problem that we use this on. So in this diagram, they tell us QR is equal to ST. So the chords are congruent. If the chords are congruent, then they're equidistant from the center. And that would tell us that C to U will equal C to V. Two x will equal 5x minus 9. So 3x equals 9. X will equal 3. They ask us to find C to U. C to U, 2 times 3. C to U would be 6. The last new concept we're going to talk about today is when we have two chord segments that cross inside of a circle. When you have two chord segments that cross inside of a circle, the products of the measures of the segments of the chords are congruent. What that means is when you take the first part of chord 1 times the second part of chord 1, it equals the first part of chord 2 times second part of chord 2. Let me show you what I mean there. In this problem, we're supposed to solve for x. We have chord segments. If you have chord segments, you take first part of the first chord times second part and that has to equal the first part of the other chord times the second part of the other chord. So here are the two chords. We have chord AB. On chord AB, the parts are 12 times x. The other chord, CD. On chord CD, the two parts are 6 times 8. So we have 12x equals 48. X would equal 4. Let's try another one of these. Once again, we have chord segments. Anytime you have chord segments, you take first part times second part will equal first part times second part. We have to learn this. So let's talk about the first segment. The first segment, we'll talk about this one. The parts of that segment are Kn times Nj. The other chord segment is this one. So on that one, we would take Mn times Nl. Now let's fill in what we know. So we know that Kn is x. We know that Nj is x plus 4. We know that M to N is x plus 2. We know that N to L is x plus 1. And now we're going to use that algebra that we just reviewed in the first week. We distribute the x. We get x squared plus 4x. Here we use FOIL. X squared plus x plus 2x plus 2. We'll combine the like terms. X squared plus 4x equals x squared plus 3x plus 2. I'm going to subtract an x squared on both sides. That leaves me with 4x equals 3x plus 2. We'll subtract 3x, and that leaves x equals 2. So we now know the x, but we were asked to find ML and JK. So let's find ML. To find M to L, we need to take 2 plus 2 and add it to 2 plus 1. We just plug in x. So for M to L, we end up with 7. And then we're supposed to find J to K. To find J to K, we need 2 plus 2 plus 4. So J to K would be 8. Okay, we covered quite a bit here. If you need to go back and look at it again or pause it, feel free to do that. You have a practice worksheet to work on for this section. So if you have questions, be sure to come to our review session from 2 to 4 any school day. Take care now and good luck on this.